I'm Sarah Clear from the Rediscovery Centre, and today I'm doing a workshop for Meath Libraries, and the topic today is the science of forces. So what is a force? A force is basically a push or a pull. So sometimes we can see them. So if I want to move the scissors across the table, how would I do it? I can push it, I can pull it. So that's basically what a force is. A force is going to move an object. Now forces can be visible, so you could see me pushing the scissors or pulling the scissors, but other forces are actually invisible as well. So a force can make something move or make something stop as well. So if I have a little ball here and I want to move it, I can push it across the table. If I want to stop it, I can use a force by putting my hand on it to stop it. A force can make something move or stop. It can also change an object's direction. So if I've got a ball that's rolling across the table and I push it to one side, I can use a force to make the object change direction. So it's something as well like a football. If a football's coming towards me and I kick it, I can change the football's direction using a force. So a force can make something move or stop or change its direction. A force can also change an object's shape. So if I've got my ball here and I want to use a force to change its shape, I can squeeze it. If I want to change an apple shape, I can use force and take a bite out of it, which is going to change its shape. If I've got a piece of paper, I can scrunch it up and change its shape as well using a force. So forces are basically pushes or pulls. Now some forces that we can see are like gravity. So gravity is a force that we can't see but is acting on us all the time, particularly as we're here on Earth. Some people ask, is there any gravity in space? It depends on what you're close to. So if I'm standing on the moon, there is gravity acting on me because anything that has mass has gravity. So there is gravity on the moon, there's just less gravity. So on Earth, if I can jump a height of 1 meter, on the moon, I can jump much higher. Because the moon is smaller, it has less gravity, but it does still have gravity. Hopefully that will make sense to everybody. Now, when it comes to gravity, there's some very cool facts. So here, I've got 2 plastic balls, exactly the same size and exactly the same weight. Now, if I drop these 2 balls from the same height at the same time, what's going to happen? Let's have a look and see. 3, 2, 1. They hit the table at exactly the same rate. Now I'm going to use one of these plastic balls and a rock. Okay, what's going to happen if I drop these 2 at the same height at the same time? Do you think they're going to hit the ground at the same time? Do you think the ball's going to hit the ground first or the table first? Or do you think the rock's going to hit the table first? Let's have a look and see. 3, 2, 1. They actually hit the table at the same rate. So if there's no air in the way, 2 objects will fall at exactly the same rate. So there's some really cool videos out there that you can see. There's one by the BBC, Brian Cox did it, and they were in this massive chamber. They took all the air out of the chamber and they had a bowling ball and a feather and they dropped them at the same time. And it's absolutely incredible to see. Because there's no air in the way, what happens is they fall at exactly the same rate, the feather and the bowling ball. Astronauts also did this on the moon. Now, because there's no air on the moon, they dropped a hammer and a feather and they actually fell at exactly the same rate as well because of gravity. So it's a really cool experiment that you can see and do at home. You could use 2 plastic bottles. You could fill them up with different amounts of water, so one's heavier and one's lighter. Drop them at the same time and see what happens. If you want to get really techie about it, you could use slow motion on your camera phone or something like that and actually see exactly what's happening as well. So if 2 objects are falling at the same, if there's no air in the way, they will fall at exactly the same rate, which is very cool. So if you had an elephant and a rabbit jumping off a building onto a trampoline, so they'll be absolutely fine, they would fall at the same rate if there's no air in the way. Brilliant stuff. Okay. So now here's an experiment that you guys can do at home all about gravity. With this one here, you're going to need 2 rulers. You're going to need a little toy car. You're going to need a ramp. So I just made mine from cardboard. So it's just as simple. It is 20 centimeters by 35 centimeters, but you can do yours any distance as well. So 2 rulers, my car. You're going to need a measuring tape. So here's one I made out of plastic. Or if you have one at home like this that your mum or dad might use as well, you can use that. So here what you're going to do is you're going to take your ramp and you're going to measure different heights of the ramp and see how far off the end the car will actually go. A really good thing to do is to do this on the ground, not on carpets, on something like a tile floor or a wooden floor or something like that. So what you want to do is you just want to let the car go. You don't want to add any extra force, you just want to let the force of gravity actually work. So if I let the car go here, you can see how far the car goes. I'm just going to get that now because it went flying off the table. Okay. So you're going to start with your ramp at a low height here. You're going to start at a height of 1 centimetre and you want to do a prediction. So how far off the end of the ramp do you think the car is going to go when the ramp is at a height of 1 centimetre? Then try 3, then try 5, 10, and then maybe 15 and see what happens as well. So it's all about the force of gravity, letting the car, giving the car enough energy to be able to go off the bottom. So you can use your measuring tape then as well to measure how far your car actually went. So it's a really good way of testing out, using fair testing, how much gravity is affecting the distance that the car is actually going. Great experiment to do. You can use different size cars. You can see if that's going to make a difference. But just remember about keeping it to a fair test. So change one thing, keep everything else the same. So you're going to start out by changing the height of your ramp and keeping everything else the same. So same car, same surface of floor. Or you could have the same height of ramp and use different size cars as well to see if that's going to make a difference to it as well. So great experiments that you can do at home. So that's just a little bit on gravity experiments. Now, as we were talking about with gravity, what happens on Earth is we are surrounded by air. And as objects are falling through the air, it actually is going to change what happens. So if we've got our ball falling through the air, it has to push the air out in front of it as it's falling through. So one science experiment to do with air resistance is what we call that. So moving through air friction, we call it air resistance. So here I've got 2 sheets of newspaper that are exactly the same size and exactly the same weight. I'm going to scrunch one up into a ball using force to change its shape. The other one I'm going to leave flat. Now if I drop these from the same height at the same time, what's actually going to happen? So with just gravity, if there's no air in the way, they hit the ground at the same time. But what's going to happen if they're 2 different shapes? Whoops. Okay, and let's let it go and see. So 3, 2, 1. This scrunched up one fell a lot faster because it has less air in front of it to push out of the way as it's falling. Now, a big flat sheet had a lot more air to push out of the way, and if you watch it as it's falling, it actually sways from side to side trying to push the air out in front of it. Like that. Okay, so that's just a little bit about air resistance, but air resistance is really useful. People use it in car design as well because they want to make things aerodynamic or able to push through the air much easier. So if you have something that's a narrow shape at the start, it's going to cut through the air a little bit more and there's going to be a less air resistance, so air that has to push out the way at the front. Really important when it comes to car design, when it comes to airplane design, and when it comes to parachute design. Because if you're a person falling through the air, you want to be going as slow as possible, so when you hit the ground you're going slowly and you don't crash land and break your legs or anything else. So here's an experiment you can do at home. All you need is some string, some plastic, so you can reuse old plastic bags or anything like that, or you can use newspaper as well. You're going to need scissors, a ruler and some tape. Then you can use a Lego figure if you have one, or a little army man, or anything really at home. And what you're going to do is you're going to create your own parachute. Now when it comes to parachutes, the bigger the better, the lighter the better, because what you want your parachute to do is catch as much air as it can as it's falling down. So if I only put string at the centre here, what would happen is the string would pull downwards and the parachute wouldn't really open. So you want to make sure it can open as wide as possible. Now you can do any size or any shape at all that you want to do. And you can test out different sizes, different shapes, different materials as well to see which one makes the best parachute. So here's one I've done earlier. Just put string on the sides of it here. You can tie them in, or you can use sellotape or whatever you want to do. And you just want to make sure as well that your army man is or Lego figure is actually hanging down from the centre as well. So I'm going to give this one a go. And 3, 2, 1. And you can see it opens out really well and it's actually falling pretty slowly. So what you can do is you can do fair testing with this one as well. If you're measuring 2 different materials, you want to make sure that each of the parachutes is the same width and length. You want to make sure you're using the same amount of string, the same weight of figure as well that you're having underneath it. And you're going to attach the string in exactly the same way. That's how to test out 2 different materials, like newspaper versus plastic. So if you want to get really inventive, you can actually do lots and lots of different shapes. Just make sure that they're the same area by measuring it all out. A little bit of maths, but it's a lot of fun maths as well. So you can do lots of different shapes, triangles, circles, rectangles, stars, whatever kind of ones you want to do. If you want to test out and compare 2 different ones, make sure you're dropping them from the same height. Make sure everything else is the same, so the same amount of string, same weight of Lego figure, everything's the same except the shape, and that's fair testing. So have fun with those parachutes. Again, stay careful, make sure you have a grown up as well to help you with that, so you're doing it in a safe way. A nice thing to do could be doing it from one of the windows, but don't lean out too far. Again, your mums and dads will help you with the health and safety of that. So that is parachutes, and lots of fun with air resistance there. So the next one I'm going to talk about quickly is the force of buoyancy. So here I've got a basin of water. Do this one outside because it does get pretty messy. Okay, so here I've got my plastic ball again. If I drop the ball into my hand here, what's going to happen is the force of gravity is pulling it downwards. If I drop this ball onto water though, will it continue falling, or what will happen? It floats on top. So even though the force of gravity is pulling it downwards, there's another force called buoyancy pushing it upwards. And you can really feel the force of buoyancy. If you hold the ball underneath the water, you can actually feel that buoyancy force pushing upwards. And if I let the ball go, pop, it pops up due to the force of buoyancy. Okay, so gravity is still pulling it down, buoyancy is pushing it upwards. Now if an object is light for its size, it will float. But if an object is heavy for its size or dense, it's going to sink. So here I've got a metal spoon. What do we think is going to happen if we put this into the water? Now this metal spoon is heavy for its size, it's dense. So what's going to happen is the force of gravity pulling downwards is going to be bigger than buoyancy pushing up, so it's going to sink. With the ball, the force of buoyancy pushing upwards is bigger than the force of gravity pulling downwards, so it floats. So that's floating and sinking, and you can test out lots and lots of different materials at home. So here I've got a couple of things to try out. Let me see now. So first of all, I've got 2 different rocks here, okay? So here I've got pumice stone that's got little air bubbles in it, and I've just got a regular rock here. So what do you think is going to happen? So if we drop them at the same time, the rock sinks because it's dense, it's heavy for its size, it sinks. But the pumice stone, even though it's a rock, has loads of air bubbles making it light for its size, so it floats. That's how you can make a rock float. So we'll take those out. Here we've got a ruler, so sometimes buoyancy actually depends on the shape as well. So some objects, if you place them flat on the water, there's air on top of it making it light for its size, so it floats. But if I push it slightly underneath the surface, so there's water on top of it now, it's actually going to sink down slowly. So you can test out lots of different materials at home to see if they're going to float or they're going to sink. Are they light for their size, heavy for their size, are they dense or not? Now, one that's kind of always got people guessing is fruit and vegetables. So here we're just going to try out a banana. What do we reckon? A banana, is it light for its size or heavy for its size? Is it going to float or is it going to sink? You might be surprised at this one. It actually floats. Now if I remove the banana from its skin and just put the banana itself in there, what would happen is the banana would sink. And that's because in the skin of a banana, it's very, very light. There's lots of air bubbles inside this as well, very, very small ones, making the whole banana light for its size, so it floats. If there's just the banana itself without the skin, it'll actually sink. And a great thing you can do at home is if you've got some Play-Doh or some plasticine or anything like that. Plasticine is actually heavy for its size, it's dense, so it sinks. But you can change the shape of the plasticine to make it float. Now, what things made of heavy materials actually float? Things like boats and stuff like that. So you can try changing the shape of your plasticine to see if you can get it to float. So I'm going to try this one out. Because there's air inside it, because I've changed its shape, it now should be light for its size and it should float. Almost. If there's any holes in it, the water is going to get into it, making it heavy for its size, and it sinks. So there we go. And you could test out things like when you've made your boat, you can put different objects into it, like little Lego men, and see how good at floating your object is. And you can keep changing the shape, make it, the bigger you make it for its weight, the better it's going to float and the more you're going to be able to get into it. So that's a really, really fun experiment you can do around buoyancy. Trying out different materials, make sure you do your prediction first, what's going to happen, and then test it out to see what actually happens. You can record it, you can do videos, maybe amaze friends and family with that as well. Brilliant. So I'm going to move all of these aside and we're going to do our next experiment. Our next experiment is magnetism, looking at the force of magnetism. So a really handy thing to do when you're doing buoyancy is to have a towel so you can clean up and you're not making waste as well, like using kitchen paper. Okay, so magnetism is a pretty incredible force. It's a pulling force that we cannot see. So here I've got a couple of different magnets. So every single magnet has an invisible force around it, the force of magnetism, which is pulling things towards it. Now, I've got some paper clips here. So you can see this force here. If I put the magnet closer to the paper clip, it actually clings onto it. And if you're very careful, you can actually create a line of magnetized paper clips going all the way down. So it's an invisible force that's pulling on these as well. So what's happening here is the magnet is making this paper clip into a temporary magnet. So there's magnetism through that as well. And you can keep going on. The stronger the magnet, the more paper clips you're going to get onto it. So if you've got any fridge magnets at home or any magnets at all, you can do lots of really cool experiments seeing just how many paper clips you can put onto it. So that's magnetism. But the thing about magnetism is every single magnet has a north pole and a south pole, okay? It's kind of divided in half, but it might be divided into different ways. So the thing about magnets is, this is a south pole, this is a south pole. If I try and push two south poles together, what happens is they push each other away. But if we put a north pole with a south pole, they attract each other. Okay, so opposites attract and like repels. And you can really see it here, you can chase it around here like this as well. Now, depending on what type of magnet it is, some of them might be round, some of them might be different shapes as well. So here I've got a really oddly shaped one, it's kind of like a cylinder shape as well. So we've got a north pole on this one and a south pole on this one as well. And they're not always marked like this, so you can test it out to see. If you've got something like a compass at home, you can put the compass, so inside the compass is a little magnet. But if you put a magnet right up against it, remember opposites attract, so this is the south pole here. And if I turn this around, you can see the magnet changing. Now again, you can do lots of really, really cool experiments like this. And you can see what the north pole and the south pole of these. Now another very cool thing you can do is if you get a sheet of cardboard, and if you have anything like iron filings at home, you might ask your mum and dad, and be very careful not to eat these. I know you won't anyway, but just in case. So I'm going to sprinkle some of these iron filings onto this. Give it a very easy little shake around. Okay. So what I'm going to do here is I'm going to get a magnet underneath, and I've got a pretty strong magnet here. And watch what happens to our iron filings. Now, iron is magnetic, so I can move all of these around as well. So can you see them all moving and standing up? And that's because of the magnetic field around it. So even though it's not touching, I can actually move these iron filings around using the magnet underneath. And you can do some very, very cool stuff as well. If I take it away, they all lie down flat. If I put it back up against it, I can move them around. So there you go. Pretty cool stuff, isn't it? A really cool experiment you can do at home using a magnet is to make a magnetic mini kite. This is using string. You've got two pieces of paper, and inside here is a paper clip, and then you've got two sheets of paper on either side of it, and tape it up so it's closed really well. So then you're going to take your magnet here, and you want to use quite a strong magnet if you can. If you put your finger down on the string here, you can make your kite fly, and if you're very careful and very slow on it, you can keep the kite flying even as you pull it away, because that magnetic force is still going to be happening. It takes a little bit of practice, but it's a really, really nice experiment to do at home as well. Now, I've got the most challenging experiment here. I'm going to have to sit down for this one because this takes concentration. So for this experiment, I've got 2 blocks of wood, and I've got a ruler going over the top. Then I'm going to get 2 magnets here, one on the top and one underneath. Okay, so the magnet underneath is actually staying in place as well. Now for this experiment, I'm going to be able to balance these metal nuts on the edge of the glass through magnetism without it actually touching the magnet. So I'm going to pull this just a tiny bit further apart. There we go. Okay. So the first thing I'm going to do is I'm going to be able to balance these nuts on the side of the glass, even though the glass is curved still, and I'm going to be able to balance 5 of them. If I try it without a magnet and I try and balance it on edge, very difficult to do. This again takes a little bit of practice, but looks amazing when you've got it done. Okay, as I'm attaching each of these magnets, you want to do it nice and slowly. Each of these temporarily become a magnet because of the magnetic field. So I'm going to stack them end to end very carefully, so you can see them one underneath the other. And you want to do this nice and slow and carefully. Okay. Here we go. It takes a steady hand and a bit of practice. So we just need one more then, and you want them all going down in a straight line. Okay, so these are all temporarily magnetized. And if I put the edge of the glass right underneath here and gently pull down from the bottom, I can still feel the magnetism there. There we go. You can still see the magnetic field is actually working as a magnet on these, causing them to be able to balance on the edge of the glass. And if I very, very gently, I can put my finger in between them, and it's still magnetized. Now the best thing is, if I move the glass very slightly, very slowly, it's balancing right on the edge of that glass, until if you move it even just tiny bit, the force of gravity pulling down is going to be greater than the magnetism, which causes them to fall into the glass. So give this a try at home, see if you can do it. All you need is 2 magnets, as I said. So guys, I just want to thank you all so much for listening today. It's been an absolute pleasure, and hopefully you've learned something about the science of forces. And this has been very kindly funded today by Meath Libraries. And if there's any videos you guys want to take, you can send them in to Meath Libraries social media, and I know they would absolutely love to see your science of forces experiments in action as well. I'm Sarah here with the Rediscovery Centre, and thank you very much.